Hello there. I'm here to somehow introduce physics. Before I begin anything in physics, I'd love to just make a little bit of clarifications on a few things, like how to solve a few things or how to express certain numbers. And this I feel is going to be helpful as we move through the journey of physics. So I have a few questions there that are going to help us discuss a few things that will actually be very important as we start the journey of our physics of physics, secondary school physics. Solve each of the following. I'm having the first question there as 40 over 100. I can easily solve that 40 over 100 to simply come up with 2 over 5 by dividing by cancelling out the zeros. So I can solve it like this. Firstly, 40 over 100. Then I cancel out these zeros, and I say 2 into 4, 2. 2 into 5, 5. But this is in fraction form, but I would need it in decimal form. In science, mostly we may lean towards the decimal way of expressing numbers that may also be expressed in standard notation. So the other way I can solve this is just by moving the decimal point. Every number that you look at where the decimal point is not shown, the decimal point, it means the decimal point is on your right side there as a subscript. Okay, so this 40 actually has a point there, but the zeros, because there are zeros after the point is rarely or it's not written because the zeros at this point are not significant. So if you're dividing by a multiple of 10, a multiple of 10 is any number which has got 1 and zeros. That's a multiple of 10. You may have multiples of 10 or sub-multiples of 10. Sub-multiples of 10 have zeros before the 1, and multiples of 10 have zeros after the 1. An example, I'll write maybe something like this. That is a multiple of 10. This can also be written as 10 to the power 3. 10 times 10 times 10. Okay, but a sub-multiple would be something like 0.003. This can also be written as 10 to the power negative 3. Okay. 10 to the power negative 3. 1, 2, 3. Oh, not 3. Sorry, this 3 has got. There's a 1 here. Okay, 10 to the power negative 3. So coming back to our question, I'll go and solve this one. Since I'm dividing by a multiple of 10, I'll have to move this point to the left. I'm dividing by a multiple, not sub-multiple, but a multiple of 10. I'll move the point to the left twice. Why twice? I'm looking at the number of zeros in the multiple of 10 that I'm dividing with. So I'm going to say 40 divided by 100, I move the point 1, 2. I'm going to have 0.4. That will be my answer. And actually, this is actually equivalent to 0.4, because if we multiply this by 10, it will give us 20. Then 5 into 20 will give us 0.4. Coming to the second one, this is a sub-multiple of 10. 10 to the power negative 3 is a sub-multiple of 10. Okay, it's equivalent to 0.001. So I'll have to raise this. I'll have to multiply the denominator by its numerator. Therefore, I'll write 1.6 times 10 to the power 3. When I multiply the denominator by its numerator, its power changes. Remember, any number that is written without a power, it's always to the power 1. Therefore, what I'm saying is any number to the power 1 is always itself. Okay, any number to the power 1 is always equal to itself, and any number to the power 0 is equals to 1. I was almost mixing those up. So any number is equals to to the power 1 is equals to itself. So any number that has been written without a power is to the power 1. So this one already has a power, so we simply raise it. If it didn't have a power, then we would have gone ahead and do our calculations as wise. So this is how it would be. This 10 to the power 3. This means 10 times 10 times 10, which will give us 1000. In other words, just look at the 3 there. That power tells you the number of zeros that the 1 should have when this expression is expanded. Therefore, we have something like 1.6 times that. Okay, so the zeros here are 3. Therefore, the same represented by this 3 in this expression. Therefore, you're multiplying by a multiple of 10. Not dividing. In the earlier expression we were dividing, therefore the point had to move to the left, but here we're multiplying, so the point has to move to the right. How many times? 3. So I'm going to have 1, the point will move 1, 2, 3. Here I'll have to put decimal places. I'll have to fill up those decimal places with zeros. So my final answer is going to be 1, 6 with 2 zeros. So 1.6 divided by 10 to the power negative 3 is 1600. Okay, then number C, we're having 2.42 exponential negative 2. This can also be expressed as the exponential negative 2. This one can be expressed as exponential 3. On your calculator, the exponential button usually has a symbol of E or EX or EXP. So instead of punching times 10, just punch this button, then punch -2 or just 2, punch your power with a minus, or if it doesn't have a minus, just punch it. Therefore, this expression times 10 is represented by EXP or EX or E, depending on the calculator that you may have. For example, on my calculator here, this is my exponent button. So if I want to write 2.42, I'll simply write 2.42, then I'll punch my EXP exponential button times, then minus 2. That is how I would write it. Do not write 2.42, then you go like times 10. It may, or it's likely to give you a wrong answer, so go for the exponent button. So coming back to this calculation here, this, when you drop this expression here, make it a denominator. You reverse what we did in the first one. Okay, I mean in the second one, you reverse. Therefore, when you have 2.42 over 10 to the power 2, it becomes easier to calculate like that even without a calculator. So it's a little bit difficult to think if you're not so if you haven't practiced enough, because the power is negative here, but when you drop it, the charge of this power, the sign of its power reverses. So this is equivalent or equal to 2.42 over 10 times 10 is 100. So the point to move twice to the left, because I'm dividing by a multiple of 10. I'm dividing, that's the key word there. So I'm going to have my final answer is going to be 0.0242. It moved from here 1, 2, because the multiple of 10 had 2 zeros. Its power was to the power 2. That would be my answer there. My next expression here is 2.4 times 10 to the power 4. This is already straightforward. The point to move 4 times to the right, because this 10 is actually 10,000. 2.4 times 1 with 4 zeros. How do I know? I look at this power, I put a comma there, then my answer is going to be 2, 1, okay, 1, 2, 3, 4. It's going to be 24,000. Okay, here simple. I think you're beginning to get the gist. 16 divided by 100. Okay, this is the same as writing it like that. Then you have the point is already here. It's here, but it's not just shown. So it will be 0.16. That would be my answer there. The next one is already in its exponent form on top there. So complete the top part, then do the bottom part, or just cancel out the 2. If you complete this, you're going to say 2.1 times 100 over 100. The 2 cancel out, and you're going to have 2.1. That will be your answer. Okay, because the 2 divide. My second set of questions is write each of the following in scientific notation to 2 significant figures. You may revise on significant figures from basic mathematics, but I'm going to express these in scientific notation or standard form if you like. So I'll go to the first one. 0.000247. Expressing this in standard notation to 2 significant figures, I'll have to move the point. Oh, sorry, I'd actually included. Let me just do this. I'll have to move the point as many times as possible to the point where I'm going to just remain with 2 significant figures. Okay, therefore I'll move it 1, 2, 3, 4 times. I can even move it 5 times. So my first answer would be 2.5. I'm rounding up because this is greater than 5. It's 5 or greater, times 10. Since I moved the point to the right, I'll have to give my power a negative sign. So 1, 2, 3, 4. I'll say -4. That would be my first way of expressing it. My second way of expressing it is where I move the point more than 4 times. So I'll say 225 times 10 to the power -5, because I moved my point to this point here. I moved it 1, 2, 3, 4, 5. Then I rounded up the 4 because this is 5 or greater. So those 2 answers will actually be correct, because the powers would actually justify how you did it, and we round up depending on what we've been instructed. For example, in this expression, we're told to simply solve to two significant figures, so I'm rounding up. The second question there is to two significant figures. Remember, the degree of significance. A significant figure is a figure in a number whose which when removed would alter the value of the number. Okay, so the greater the significance of a figure in a number, the greater the number will change if you were to remove that figure. So in a number like this one, 2 is the most significant than this value here. And in a number like this one, the significance is always the same, but the 2 is the most significant here because it gives you the value, the magnitude. Therefore, as you go to the right, to the left, significance increases. As you go to the right, significance or importance reduces. So I cannot put 2 zeros here. I'll have to move. My point is here, and my most significant figures are 2 and 4. So I've been told to write to two significant figures. So I'll simply move my point 1, 2, 3, 4, 5. I have 2.5 times 10 to the power. I moved the point how many times? 1, 2, 3, 4, 5 to the power 5. Since I was moving my point to the left, my power is a positive. I can even write this as 1, 2, 3, 4. 24, let me say 25 times 10 to the power 4. Okay, I've rounded off because the 9 is greater than 5, equal and greater than 5. Those will be my two ways of writing these answers. Here, writing to do these significant figures, I'll just say 4.0 times 10 to the power negative 1. Okay, I moved the point twice just for me to have this 4 and a 0, two significant figures. In this case, I've made my 0 significant because it just has to be shown. Okay, because we need two significant figures. The next point there, to two significant figures, I'll write 5.1 times 10 to the power 1, 2, 3, 4, 5, negative 5, because I was moving the point to the right. Okay, and the point has to move to the left for you to have the actual number. The other way is writing 51 times 10 to the power negative, yeah, that's correct, 6. Imagine these can actually be measurements. These can actually be ways of measuring different physical quantities. So these ways of writing numbers are pretty important as we begin our physics. The next one, to two significant figures, I'll write 2.9 times 10 to the power 1, 2, 3. 1, 2, 3. The point is here, so it moves 3 times, positive 3, because the point has to move to the left. Or you can even say 29 times 10 to the power 2, because the point moves twice. So I round up this 8 to 9 because the number after it is actually greater than 5. It's 5 and greater. Here we're having a number like that one. The most significant is this one. The point is already there, so I'll move my point. It's going to be 1.0 times 10 to the power 1, 2, 3, 4. Okay. 4. 1, 2, 3, 4. Yeah, basically that's how I would express these numbers in terms of a standard form or scientific notation. Hopefully this was helpful. Remember to subscribe and leave your comments below. Thank you.